Hello, today I will tell you about the project I executed through the Kaggle program. My project is named Large Language Model for Answering Scientific Questions, and the one speaking to you is Engineer Josué Huamán. I'm an electronic engineer with a degree from the National University of Callao. Currently, I am pursuing a master's degree in embedded artificial intelligence at the University of Buenos Aires. I have a background in software development, and my experience with machine learning and NLP exceeds 1 year. I joined this program to explore NLP further and apply it to professional projects. In the future, I aim to delve into multimodal artificial intelligence and emerging languages. So the project goal is to deploy an efficient natural language model for answering complex scientific questions with minimal resources in a constrained setting. Inspired by a Kaggle competition, it evaluates the efficacy of smaller models in handling ChatGPT-generated questions. Skills acquired include working with LLMs, optimizing performance with GPU, implementing time-saving techniques, indexing knowledge bases, fine-tuning pre-trained models, and deploying the complete workflow to production. So what's an LLM? An LLM, or large language model, is a versatile NLP model used for understanding and generating text, aiding in tasks like translation and summarization. However, relying solely on LLMs has limitations, as they cannot easily expand their memory, lack transparency in predictions, and might produce inaccurate information. Hybrid models, which combine parametric and non-parametric memory, can address these challenges. So, in order to solve this problem, I was inspired from the paper Knowledge Intensive NLP Task, and I used the multi-QA NP-net model as the query encoder. I use a face library for the document indexing and the Verta as the generator in my solution. Although the paper recommended fine-tuning the entire pipeline, I choose to fine-tune only the generator, keeping simplicity and time constraint in mind. The solution consists of three blocks working together. The search block obtains the question's numerical representation, searches for related articles, and retrieves relevant context from Wikipedia. The tokenizer block converts text into tokens for model processing, and finally the prediction block makes the final prediction. As I mentioned earlier, fine-tuning have to be applied only on the generator. So for this, I have to make an EDA over the data. The idea was to determine if there were any missing values or see if the data is balanced or not. Also, an EDA was performed over the Wikipedia articles to see how it is formatted. This analysis, with this analysis, I could figure out that there were a relationship between the number of tokens of the different elements. I mean, the articles, question, and options. And this information was very important because it was necessary while I was going to work on the inference part of the project. Here is the implementation of the pipeline class that includes both the retriever and the generator. With this implementation, inference was conducted on the test dataset provided by Kaggle, resulting on a score of .71. Here are some of the notebooks that were necessary in order to complete this project. And finally, I have a little video where I'm showing how the model is performing. I'm gonna give the model real scientific question, and I will see how if I can get the answer with accuracy. For the first question, the expected answer is carbon dioxide. Let's see if the model can figure out the answer. Yes, it get the right answer. The second question is, what is the process by which plants make their own food using sunlight? The expected answer is photosynthesis. For the final question, which is what is the chemical symbol for the element gold, the right answer is letter B. Here are some of the links of all the documentation that was necessary in order to complete this project. Well, that's it. I want to give a special thanks to Arash, Claudia, and Ray for the constant support and motivation through the project. Thank you.